Hello everyone, welcome to my free online tutorial for the new SAT Math section. Now the problem that you see on your screen right now is taken from the first exam contained in the official SAT study guide just released by College Board that is meant to help you prepare for the new SAT exam issue coming up in March of 2016. So this problem is again from the first exam, problem number 36, problem number 36 in the calculator section. Okay, so this problem allows you the use of calculator. So this problem is a typical algebra problem. Okay, so it says for what value of x is the function h above undefined, right? So now you know that in order for this function to be defined, and since this function presents a fraction, you know that a fraction is defined when the denominator is not equal to 0. Right? So when the denominator, this whole thing here, is equal to 0, this fraction will be undefined, and so is the function, because the function is the fraction, right? So we must find the value of x that makes the denominator 0. Okay, and this is what they're asking for. What value of x is the function h above undefined, right? There's one value only. So this is a good piece of information. One value, because there's only one answer possible, right? It's a fill-in answer. It's you must grid it in. So there are no choices available. So let's see. So the first thing I would suggest to you is that noticing that there are two terms that are the same. One of them is squared and the other is not, right? Which is x minus 5 squared plus 4 times x minus 5 plus 4. That makes me feel like there is a substitution. How do I know that? Because I see this 4 before the second term and the 4 as the last term. So I'm thinking of something that I can square, right? So here's how we're going to do it. We're going to make a substitution. We're going to let x minus 5, which is the repetitive term, right? X minus 5, we're going to let it be a. Okay? So as a result, if we make a substitution for x minus 5 to be a, we have the following denominator. A squared, right? Because this whole thing is a, x minus 5, a squared plus 4 times a, right? Because 4 times x minus 5 plus 4 is equal to 0. And remember, this is the denominator, not the function itself, the denominator. We're setting it to 0 because we want to find the value of x that makes it undefined, the whole function. Okay? So after that, we can expand it. You see that this is a perfect square, actually. If you do it a plus 2 times a plus 2, it produces this polynomial, a squared plus 4a plus 4. Right? And if you know that it's a perfect square, you can just leave it in the squared form here. So now, after you've gotten to this form, you can substitute your values back. Now that you've found this perfect square form, you can substitute your value of a back to x minus 5. And how's that going to be? A turns to x minus 5. So we copy this thing down with the switched back substitution again for x minus 5. So this becomes this, x minus 5 plus 2, and this whole thing is squared, is equal to 0. And after that, it's easy to just perform the operation, addition, that is, from minus 5 to plus 2, right? So we're going to add 2 to minus 5, and we're going to get minus 3. So x minus 3, and this whole thing is still squared, right? Is equal to 0. Now what do? We get rid of the square by taking the square root of both sides. And 0 is just always 0. No matter what you do to it, it's 0. That's the beauty of it. So x minus 3 is equal to 0, right? Which produces x is equal to 3. Right? So 3, the x value of 3 makes the function undefined because the x value of 3 makes the denominator 0. Okay? Now suppose that you didn't know how to do this. So suppose that you didn't see this coming. You didn't really understand how this works, how you can do the substitution, or how you can even see it without the substitution. Now without the substitution, I give you good news because you can still expand it, right? You can expand this denominator by performing the square of this and then multiplying 4 times x minus 5, and then putting everything in this form. Only your a's will not be there. There will be x's in different numbers. It's not going to be 4 and 4, but in this form you're going to transform this whole thing. And when you do that, you actually have x squared minus 6x plus 9 is equal to 0. So when you work this out, when you expand it, right, when you simplify this thing, you will have x squared minus 6x plus 9, right? And you're going to set that to, equal to 0 as well. And what do you think is going to happen? X squared minus 6x plus 9 is a perfect square because it is x minus 3, and this thing is squared is equal to 0. Right? So x squared minus 6x plus 9 is the same thing as x minus 3, and this thing is squared. Okay? So you're going to set it to 0, and then you're going to arrive at this result. This is what you're going to have. Okay? So these are just two ways of doing this problem. So whatever comes to your mind, do it quickly, because I mean there's no way to really factor this out immediately. You should do it either the substitution, or you can avoid the substitution by just seeing your a as this big chunk already. Then you don't have to carry on this substitution. But I just want to tell you how this works, show you how this works, so that you know in the future that maybe you can avoid having other variables and you can see it right away as a, right? And you can work with x's. But if you feel like you can't see them, you can just simply simplify this to produce x squared minus 6x plus 9, or whatever is going to be on another question, whatever the numbers will be given. You can just do it this way, and you will still arrive at the right x value that produces the value of 0 for the denominator, which makes the function hx undefined.